Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with 8th grade, Module 4, Lesson 16. Let's get started. In yesterday's lesson, we learned about slope, which is a value for the steepness of a line. And we learned that we could take from one point, say right here, this point, and I could count up 3 and then write 1, and we know that slope is the change in y, which would be a 3, over the change in x, which is a 1. So slope of 3, and that's correct and good. As long as we have a graph, we can certainly do that, but we're not always going to have a graph. At some point, we're just going to have an equation and maybe a few points, and we need to be able to calculate the slope. So we're going to use an equation to help us calculate slope, and that is it's just the change in y over the change in x. Well, how do we find that? Well, we just take one of the y's, we'll call it the second y, and subtract away the first y. That'll be the change in y, and then we'll take that same point, the second x, and we'll subtract away the first x, and that'll be the change in x. So if we can do that, have two ordered pairs, and we can subtract away and find the change in y and the change in x, that will be slope, and we don't need a graph to be able to figure that out. So let's see if we can do that. Let's show you what that looks like. If I do use the points that I've got here, this first point is the point 2, 1, and the second one is the point 3, 4. 3, 4, and that one's right here, and there's the first one, 2, 1. Okay, I want to make sure that I don't confuse myself, so I'm going to name my points. And I'll say that this is going to be my first point, x. So that's my first x point, or x1. This one will be my first y point, or y1. And then my second point will be this one up at the top, and that will mean that my the first x value here is the x2, and then that'll be y2. So the x value from the second point and the y value from the second point, and then down here this will be the x value from the first point and the y value from the first point. All right. Well, now I just need to substitute. That's it, substitute. So I'm going to use this equation, slope equals, and I just need my y2, and that's a 4. So I'm going to take that 4 and substitute it for y2. And then I'm going to subtract away y1. Well, my y1 is a 1. So 4 minus 1 goes on top. That's my change in y. And then I need a change in x. So I go to my x2. My x2 is a 3. Minus my first x is a 2. So 3 minus 2. And then if I just simplify, 4 minus 1 is 3, 3 minus 2 is 1, so the slope is 3, and that matches what we found over here. So we can see it from the graph, but we also need to be able to calculate it from the ordered pairs, and that's how you do it. You use that equation to calculate slope, the change in y over the change in x. All right, let's try another one. Just need a couple of points. Really doesn't matter what points I use. So to just show you, I'm gonna use this one down here, which is the point -1, -1, and I'll use one way up here, and that's the point 2, 5. So 2, 5, and because both of these points are on the same line, I can calculate the slope with any points on the same line. I'll get the same slope. So again, we're going to use slope equals my second y minus my first y, the change in y, over the change in x, which is my second x minus my first x. So got to stay consistent and corresponding. So if I start with, for example, if I say this is going to be my first point, then that's the x1 and the y1. And if I say this is my second point down here, then this is the x2 and that's the y2. Okay, and then I just have to stay consistent and corresponding when I substitute here. So slope is equal to my y2, I said, was -1. So -1 minus my y1 is 5. It's up here. So it's -1 and a -5 over my x2. My x2 is a -1 minus my x1, and my x1 is a +2. Okay, and then when we calculate this, we get a -1 and a -5 is a -6, combining like terms. A -1 and a -2 is a -3. And then I can simplify. 6 divided by 3 is 2. And a negative divided by a negative is positive. So the slope is 2. And I can see that if I just count, if I count from this point up to right 1, slope of 2. Up to right 1, slope of 2. Up to right 1, another slope of 2. So I can use the equation to calculate slope if I don't have a graph. All right, let's look at another one. Any points I want. I'm going to I'll mix it up and I'll just go way down here. And I'll use this point and that point. Just wherever they cross at an intersection. So this first one I have is 8, 5. 8, 5. And the second one is 11, 7. 11, 7. And I'll use those 2 points to calculate slope. I just have to, be careful to name them. And I don't know. Let's make this x1, y1. And we'll make that one x2, y2. It really doesn't matter as long as I keep them consistent. I can't have an x1 with a y2. Those are values from different points. So x1 and y1 are together, x2 and y2 are together. It's really like saying these are the x values and the y values from my first point, and these are the x and y values from my second point. And you can mix them up, it doesn't matter. In fact, I'll show you both on this one just to make sure that we understand that. So I'm going to use this slope equals y2 minus y1 over x2 minus x1. And I'll just plug that in the way we have it now in the blue, and then I'll switch them around, and you'll see how we get the same slope. So y2 is a 7, so I get m equals 7 minus my y1 is a 5, so 7 minus 5. That's the change in y. And then the change in x would be x2, which is 11, minus my x1, which is 8. 7 minus 5 is 2. 11 minus 8 is 3. My slope is 2/3. Okay, let's switch this around now, and let's call the 8, 5 point my x2 and y2, and let's call the 11, 7 point my x1 and y1. And we'll just flip that around and see if we get the same slope. Slope equals, well, now my y2 is 5, and my x2, or my y1 is 7, so it's 5 minus 7. And then my x2 is 8, and my x1 is 11, so it's 8 minus 11. And I get -2 divided by -3. And a negative divided by a negative is positive. So my slope is 2/3. No matter how I set it up, as long as I use 2 points on the same line, I stay consistent, corresponding with my x and y values from each point, I'm going to be able to calculate slope. And it doesn't matter which points I use. I could have used, this one and this one. Still going to get the same slope. Still going to be a up 2 and a right 3. And we can see that with the graph. Up 2, right 3. Up 2, right 3. Okay, and up 2, right 3. Up 2, right 3. It just continues to follow that pattern. Every one of those points is on the same line. It's going to have the same slope. All right, last one for today. Let's choose a negative, one of these in the third quadrant, negatives. And we'll choose that one on the y-axis. Okay, so the negative is -5, -5. And the positive one up here on the top is a 0, 5. 0 left or right puts me on the y-axis, so 0, 5. And then, I can call them what I want, so I don't know. We'll go this is a x, let's go with this x2, y2. Doesn't really matter, x1, y1. And we're going to use slope is equal to y2 minus y1 over x2 minus x1. My second y minus my first y. That's the change in y. And then the second x minus my first x. That's the change in x. And we have to keep those the same and in order, or we're going to get the wrong answer. So substitution. Slope equals, well, y2 is right here. It's a -5. So -5 minus my y1 is a 5. So -5, -5 over my x2 is a -5 minus my x1 is a 0. So we get -5 and -5 is a -10 over a -5 minus 0 is a -5. Negative divided by negative is a positive, and 10 divided by 5 is 2. The slope is 2. And we could see that. Up 2, right 1. Up 2, right 1. We get right back on the line. Up 2, right 1. Up 2, right 1. Right? That's the slope. If we use 2 points and we find the slope, that is the slope of the line, no matter what 2 points we use. Okay, that is lesson, what? I don't remember, 16, I think. Check it out at the beginning. Hope that helps. See you again next time.